So sketch the polar curve given by r of theta equals 2 cosine of theta. Okay, so I'm going to give myself some space because this can be a job. Okay, so let's give ourselves some axis like this. And let's start this. So as we range theta from 0 to pi over 2, let's see what's happening. So it's helpful to have a graph of cosine 2. So let's put the graph of cosine up. So cosine looks like this. So this is pi over 2. Yeah, this is pi, and then this is 3 pi over 2. Okay, so as we range from 0 to pi over 2, which is this range of angles like this, we're starting off at 2 right here. Yeah, so this is where we start. So this is r of 0, and here is, and it's at 2. Right, so that's here at 2. And then as the angle goes from 0 to pi over 2, the r, which is cosine of theta, right? The r of theta is decreasing, 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 right? So that when we are actually at pi over 2, then cosine of pi over 2 is 0, so the radius is 0 then. So as we go along like this, so for each r we have a different, start again, for each theta we have a different r, right? And they're definitely decreasing. So the really kind of, if you're really stuck, the way to do this is to like give yourself some particular angle like this, and then just plot the point r where you think it is. So we could do that, right? So like this, and so whatever this angle is, say somewhere like this, so it's smaller than this thing. This angle here is somewhere like this, so it's smaller than this thing. But as you get more experienced doing this, then you can just sort of do it in your head. So imagine as you range the angle going along this part of the graph, right? So this is the angle here. And as you range the angle, then the r is given by this length here. This is r of theta. Well, this should be like, if I'm going to do that, then I should call that height 2. So this is the graph of 2 cosine of theta. Yeah? So r of theta is decreasing, 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 and when we actually have the angle pi over 2, then it's actually just 0. So when you have an angle like this, which is close to pi over 2, then this r is very small, and when we are at pi over 2, then it's 0. So if we try and plot that, what's it going to look like? It's going to kind of look like this, right? Like this, right? That's the shape we get as we plot over this part of the graph. Or this range of angles, I should say. That's a better way to say it. So this range of angles gives us that. Let's change colors. So the red is harder to see, but changing colors is important. Now let's go from pi over 2 to pi. And what's complicating things here is that we have a negative r. Right? So I like to do things one thing at a time. So I'm not going to plot r of theta. So let me just specify that this thing right here is r of theta over that range. If I try and plot r of theta over this next range, I have two things to worry about. I have to worry about the angle, and I have to worry about the fact that it's negative, so it's on the opposite side. And I don't want to have to do both at the same time. So I'm going to plot instead r of theta absolute value. Okay, I'm going to plot r, well, strictly speaking, what am I plotting? I'm plotting this point, and I'm going to plot this point instead, as I range the theta from pi over 2 to pi. So let's do that. So as we're going along like this, then r is 0 and then gets more and more negative, but the absolute value therefore is growing. So if we just drew the absolute value, then it's something like this, right? So then for angle which is a bit bigger than pi over 2, then we have this r like this, which is small, but it's growing. And then if we have an angle like this, then it's still growing more. And when we are out here at angle pi, then we have distance 2. So if you do that, you'll see like we start small, then it keeps growing, keeps growing, keeps growing, keeps growing. The r keeps growing. The r keeps growing as the angle goes more and more towards pi over 2, and it ends up like this. So this is this, right? As the theta ranges from pi over 2 to pi, this is this, right? I should write that better. Okay, but that's not our job. Our job is to actually plot r of theta, right? So we have to now going to take account of the fact that we just took the absolute value and the real thing has got a negative sign. So we were plotting along like this as theta ranged from pi over 2 to pi, but now the real guy, the guy we're actually interested in, which is r of theta, let me take a different color, this one. The real guy is in exactly the other side of 0 from it. So the real guy, the guy I'm interested in, is here. So when we're here with this guy, then r of theta is actually on the opposite side, right? Because r is negative, so the real guy, r of theta, is minus absolute value r of theta, right? So this guy goes to this guy goes to this guy, this guy goes to this guy, this guy goes to this guy, and so on. So if we do that, then what we find? We find that what we're actually plotting is this. So this is the thing that we're meant to be doing. So this is this thing. So we put little circles around like this to indicate. So this thing is this thing. So this is the part of the graph of r of theta as we range from pi over 2 to pi, right? And when we're back at pi, we end up exactly back where we started. So as we go and range the angles from 0 to pi, we end up doing like this. So I'm writing r of theta, but typically you're just going to be asked to plot the graph of r of theta. So that's just a convention just to simplify things, but what it actually means is plotting all these points r of theta, which is what I've been doing here. So this is actually, you'll be asked for the graph of theta goes to r of theta. Okay, cool. So we've done this part. And now we have to do this next part. Let me see if I can get some other color. Blue. So now we're going to do this part here from theta to from pi to 3 pi over 2, right? And we are here, but again, over this part we have negative r, and I don't want to deal with two things at once, so instead I'm going to plot this guy, absolute value r of theta, right? So absolute value r of theta at pi is here, and then what happens as we go over this part here? We go over this part here. Well, we are going to go from 2, smaller, to 0 when we're here. So then we're going to do something like this, right, with the same kind of arguments. So this thing here will be the graph of theta absolute value theta, like this. And that represents this thing here, right? That represents this thing here. But again, it's not the real guy. The real guy we're meant to be doing is r of theta, not absolute value. But all we have to do is to reflect it. So whenever we have this guy, it corresponds to this guy corresponds to this guy this guy corresponds to this guy. So if we do this, we find that as we go over this part from pi to 3 pi over 2, we're just going to be looping around where we've been before on this part, right, like this. Yeah? Cool. So that's what happens as we go from here to here. All right, final part. The final part is from 3 pi over 2 to just 2 pi here. Okay, and now we're in the happy situation of having a positive r again, so we don't have to worry about doing absolute value of r first. We have a positive r. And when we are at 3 pi over 2, then the r is 0, and then it grows steadily up to size 2 when we're at 2 pi. And sure enough, we know that this guy puts us here when theta is 3 pi over 2, right? So as we keep going from 3 pi over 2, and 3 pi over 2 is like over here, right? And we steadily increase, so this is where we are. We are indeed going to be doing this kind of thing, mapping all around. So for example, this point here is the angle 3 pi over 2 plus whatever this angle is here, right? So this thing corresponds to this thing, right? And then this angle here is going to like correspond to this angle here, yeah? It's all the way around like this. And all that time, the radius is increasing, right? This is increasing until we get back to 2 like this. So what does this parametric curve actually do? We start off here, right? Let's do it again. From 0 to pi over 2, we go around like this. From pi over 2 to pi, we go around like this. And the way we figured it out was first by thinking about the absolute value of r theta, and then doing the fact that we know that minus r is just reflecting across the origin, right? So from here to here, we're going around like this. So we at pi are back here where we started. So r of pi is actually here. Because the absolute value is over here, right? But r of pi is negative, so we're here. And then from pi to 3 pi over 2, we do this loop on this side again. And then from 3 pi over 2 to 2 pi, we do this loop back again. So we're wrapping twice around this circle with this parametric curve. Okay, if you've never done this before, this isn't going to sink in the first time. This is a new skill you're going to have to develop. If you're absolutely stuck and you can't, if this just seems meaningless to you and you think, I'm never going to be able to do something like this, do not panic, because at worst, it's just like going back to the early days when you're learning to plot a graph. You can just create a table. You just create a table of angles, and then r of theta, and then you just put in the values. I think I did some already. So we're going to have angle 0, pi over 6, pi over 4, pi over 3, pi over 2, and then we go 2, root 3, root 2, 1, 0, right? So then you can just go, okay, we are here at angle 0, an angle pi over 6, say it's this thing. If this was pi over 6, then the radius is root 3 like this, so just do root 3. And then when the angle is pi over 4, which I guess looks like this is the angle pi over 4, then the radius is root 2, which is even shorter, so it's like this. And you can just, maybe draw a different picture, you can just, for each radius r, so for each angle, you just plot what the r is. So pi over 6, something like this, pi over 4, something like this, pi over 3, something like this, and then pi over 2, it's like 0. So you just plot them and then just put a curve through all these points. So you can't be defeated with this task. Ultimately, you can just make a table, make it as fine as you like, and connect up the points, and you'll get there. But you want to get out of doing that because you'll be facing exam questions where, if that's your method, you just can't possibly complete the exam, right? So you've got to build your geometrical intuition for visualizing how polar curves are going to look. And this kind of way of doing it is one way to do it. Maybe you can find a different way that works better for you, but this way works for me. But whichever way, you've got to learn to be able to do this. You've got to build this mental muscle of being able to sketch the polar curves and later be able to recognize the polar curves. And that's one of the new things you're going to have to learn in this last part of the course. Okay, that's it for today.